Now we're moving on to part 4, where we're talking about solving your solving equations with the quadratic formula. So if you find that your quadratic is no longer factorable, what we can do is use the quadratic formula. So factorable doesn't mean that it's not solvable. So we're using factoring over here to get your solution. But notice that your solutions come out nice and clean, whereas the other parts, we've noticed that some of your answers, they don't always look super nice. So in that case, we can have a tool in our back pocket called the quadratic formula. Now the quadratic formula goes x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now these a, b's, and c's are coming from the quadratic equation ax squared plus bx plus c is equal to 0, where this a matches the a's over here, this b matches the b's over here, and this c matches the c over here. We always want to make sure before we get started that all of your quadratics are in this form already. If things are to the other side and they're not set equal to 0, we want to bring them over and write in descended order. So let's take a look at number 21. So first thing we want to do is make sure that we're in descended order. And for the time being, I might just write our quadratic equation up here to help us follow suit with your quadratic formula. You can also write out your ABCs to help you keep it in line if you want to. It's just a little redundant, but just in case we need it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what we're going to be following. So we have x is equal to, actually, before we get started too, we always still want to look for a GCF between our numerical values and even our variables, which unfortunately in this case, nothing does come out. But the reason for checking your GCF is that because we're going to start to multiply here, some of our numbers might get very, very big. And if we can have a chance to reduce those values, we're better off doing it with the GCF. So you have negative b plus or minus the square root, and we're going to put b here, which in our case is 7, into parentheses, just because if it were negative, notice that it does change things considerably with your leading term. We have minus 4 times your a times your c all over 2 times a. Now we can go ahead and start to chip away at your equation by simplifying. We get 49. The double negative will go away and into a positive. So 4 times 4 is 16. Or if you want, 4 times 7 is 28. 28 times another 4 is 112 all over 8. And we're going to slowly start to chip away at it continuously. So 49 plus 112 will get you to 161 all over 8. Now 161, 161 is not a perfect square, but we can kind of figure out, can it reduce any further? With it being a rather large number, we can figure out that perhaps there might be something in it. So, and it being odd, 2, 4, so 4, 16, that won't work. Okay, so 161 is not able to be reduced any further. So this should be your final answer here, because the square root of 161 cannot reduce any further, and will have to remain. So let's try it again with the very next one. Checking for a GCF. Unfortunately, again, we do not have one. Yes, 5 and 15 have a 5 in common, but your middle term 4 does not have a 5 in common. So we cannot pull that out. So we can try out your quadratic formula. If you do find that it's factorable, I always think that factoring is quicker and easier. And sometimes when you do the quadratic formula, and if your numbers come out nicer in the end, if you can get rid of your square root, it just means that it is factorable in the end. So we're gonna put it back into the quadratic formula, which again, I will start to bring down here in case you need to follow our work. So negative b less or minus the square root, and I should put this into parentheses, building some good habits, 4 squared minus 4 times 5 times negative 15 all over 2a. You got negative 4 plus or minus the square root of 4 is 16. So then we have negative 4 times negative 5 is negative 20 times 15 is 300. And that's going to be a positive 300 because the negative will disappear over 10. So we get 16 plus 300. 316 over 10. Now 316, being a positive number, we can try to find a perfect square in it. So 316, a perfect square that they have in common is a 4. So we can get 2 root 79. And 79, I do not believe has anything in common. So we'd have to keep it that way. Negative 4 plus or minus 2 square root of 79 all over 10. Let's see, 10 and 10, 4, 4, 2, and 10. Now that everything out has something in common, we can actually go ahead and reduce. So we can say this is minus 2 plus or minus the square root of 79, I can't talk today, all over 5. And we're going to try one more here. So notice that it is not set equal to 0. So we want to make it set equal to 0. So we'll pull the 3 over, put it into descended order. Looking at a GCF, do we have one? No. So we can pull out your ABCs over here. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So we can say negative 7 plus or minus the square root of 49 plus, because your double negatives are going to cancel. I always recommend writing your sign first. But anyways, we have 4 times 11, so 44 times 3, which is 132 all over 22. Going ahead and keep cleaning up that number. We have 49 plus 132 is 181 all over 22. And then looking at 181, we can figure out if we have anything to reduce. And that is your final answer. Make sure that we try some of the other ones on the other side, just to get some practice.